Hello everyone, I am Alok Singh, currently pursuing my BCA from IIPSTV Indore. So now I am going to solve the question of paper of first internal set T A. So the first question is find the cube root of 12 using Newton Raphson method. Correct up to 4 plus 8 of decimal. We know that x cube equal to 12, x cube minus 12 equal to 0. Hence f x 1 fx equal to x cube minus 12, f dash x equal to 3x square. We know that yi plus 1 equal to xi minus fxi upon f dash xi equal to xi minus fxi value is xi whole cube minus 12 upon 3x square I. We know that the cube root of 8 equal to 2 and cube root of 27 equal to 3. Our result must be between 2 or 3. Let x0 be the approximate root of 12 is 2.5 for the first iteration I equal to 0. So x1 equal to x0 minus x0 whole cube minus 12 upon 3x square. x1 equal to 2.5 minus 2.5 cube minus 12 upon 3.255 whole square. x1 equal to 2.3067. This is x1 values. For second iteration I equal to 1, x2 equal to x1 minus x1 cube minus 12 upon 3 x1 square equal to 2.3067 x1 values minus 2.3067 cube minus 12 upon 3.2307 of whole square. x2 value is after calculation this equation equal to 2.2894. For the third equation I equal to 2 equal x3 equal to x2 minus x2 whole cube minus 12 upon 3x square 3x2 whole square. x equal to 2.2894 minus 2.2894 cube minus 12 upon 3 into 2 upon 2.2894 square equal to after solving the equation we find the third iteration value is 2.2894 and its cube root is 12 is 2.2894 approx because for second iteration and third iteration value is approximate 2.2894. So let's solve the second question of first internal. Find the cube root of 12 using fixed point iteration method. Correct up to 4 places of decimal. The first is so let's see the algorithm of iteration method. So first it will read x0, e and n. x0 is the initial guess, e is the allowed error in the root, and n total iteration to be allowed for convergence. Second step is x1 to gx0 remarks step 4 to 6 are repeated until the procedure converts to a root or iteration region. Third step is for f I equal to 1 to n in steps of 1 to 4th. x1 is x0 and x1 value is gx0. Sixth step, if x1 minus x0 upon x1 is equal to or greater than smaller than e, then go to 9 in for. 7 step is right does not converge to a root x0 and x1. 8 step is stop. 9 step is right converge to a root I and x value. Step 10 is stop the algorithm. This is the fixed point iteration method algorithm. So let's solve the third question of first internal set D. Guess the output of Gauss-Jordan algorithm for matrix 10 minus 7 3 5 6 minus 6 8 minus 1 minus 4 5 3 1 4 11 2 5 minus 9 minus 2 4 and 7. So let's solve the matrix from Gauss-Jordan algorithm. R2 convert to R2 minus R1 into 6 upon 10. After solving the R2 minus 0.6 R1, R3 becomes R3 minus R1 into 3 power and 10 equal to R3 minus 0.3 R1. R4 becomes R4 minus R1 into 5 upon 10, R4 minus 0.5 R1. So solve the matrix. We find the 10 minus 7, 3, 5, 6, 0, 3.8, 0.8 minus 1, 8.6. After solving the matrix, we get this matrix. And again, R1 is R1 minus R2 minus 7 upon 3 by 8. After solving this equation, giving the R1 plus 1.8421 R2. And R3 convert to R3 minus R2. 3.8 upon 3.8 equal to R3 minus 0.8157 R2. R4 value convert to R4 minus R2 into 5 minus 5.5 on 3.8. So R4 plus R2 into 1.4457. After the convergence, we get this matrix, and from this matrix we allow to convert the row 1 into row 1, convert to R1 minus R3 into 4.4737. R2 equal to R3 minus R3 into R0.8 upon 2.474, and R4 is R4 minus R3 into minus 2.3422 upon 2.4474. After solving the equation, we get the matrix of this. So again, we change the row 1 into row in R1 minus R4 1.5 minus 15.916992, and R2 equal to R2 minus 4 R4 into minus 4.3732 upon 9.9248. Okay, so we find the matrix. After solving the whole equation, we get the matrix A. This is from this matrix we calculate the x1 value. From x1 equal to 10, x1 equal to 4.99, and x1 equal to 4.999, x1 equal to 5 approx. Now the calculate x2 value. X2 value is 3.8 x2, 15.2036. X2 value is 4 approximate. Now again calculate the x3 value. X3 value is 2.4774 equal to minus 171310. After calculating the value, x3 equal to minus 1 and minus 7 approx. Now x4 values calculating. X4 value is 1, hence x1 equal to 5, x4 equal to 4, and x3 equal to minus 7, and x4 equal to 1. This is a solution of the third question of Gauss matrix algorithm, Gauss Jordan algorithm for question 3.